Hi there. In this video, we'll show you how to set up an Aqueduct server that uses Kubernetes and how to run a full workflow on your Kubernetes cluster. To begin, we first need to set Aqueduct up to run with an external artifact store. An artifact store is simply where Aqueduct stores its intermediary code and data snapshots. In this example, we'll be using a Kubernetes cluster running on AWS EKS, so we'll use AWS S3 as our artifact store. Connecting Aqueduct to S3 is easy. We navigate to the integrations page, click on the S3 icon, give our S3 bucket connection a name, and tell Aqueduct the name of the bucket as well as where it's running, and give Aqueduct a path to our credentials. We tell Aqueduct to use this integration for artifact storage, hit confirm, and when we hit confirm, Aqueduct will attempt to migrate any metadata we've previously stored locally to this new bucket. We'll hit refresh to make sure that the integration migration worked as expected, and we can see that Aqueduct reflects the new artifact storage. With this done, we can now connect Aqueduct to Kubernetes. We first give our Kubernetes integration a name, tell Aqueduct where the kubeconfig file that has access to this particular cluster lives, and tell Aqueduct the name of the cluster. We hit confirm, and we're ready to go. With our Kubernetes connection set up, we're ready to dive into some code. In this video, we're going to build a pipeline that analyzes the sentiment of some tweets about Game of Thrones Season 8. I've already put those tweets into a bucket that I've connected Aqueduct to, and we're going to use the Hugging Face Transformers library to estimate the sentiment quality, positive, negative, or neutral, of each one of those tweets. First, we'll go ahead and create an Aqueduct client, and we'll use the Aqueduct client to load a connection to our S3 bucket, we've called it datasets, and read the CSV file that has our tweets in it. You'll notice that I've set the execution mode to lazy here. That's just because some of the functions in this notebook are going to take a little bit of time to execute since they're using deep learning models. This will make sure that we don't repeat computation and only ask Aqueduct to execute our code when we want it to run. Here, we can see that we've called .get on the tweets object, and we can see a preview of the tweets dataset right here in the notebook. Now that we have our data, the first thing we're going to do is write a function to tokenize our tweets. We're going to use the Hugging Face auto-tokenizer library that we're importing from the Transformers package right here. And the code that's in this particular function is actually adapted pretty directly from the Hugging Face documentation. I won't go into the code in detail, but you can find a link to the full documentation in the description below. What you'll notice that we've changed here is that we've added Aqueduct's @op decorator above the function. We've specified in the decorator that we'll be using the EKS US East 2 integration that we connected a few moments ago. And we also ask Aqueduct to ensure that the Torch and Transformers libraries are installed when we run this function on Kubernetes. Finally, we use the resources map to make sure that we are executing this function with the right amount of resources, in this case, 15 gigabytes of memory. And with this configuration done, Aqueduct will automatically construct a containerized environment that has all of the requirements, the packages, the memory, and so on that we've asked for. We can define this function and come down here and use the Aqueduct API to create a couple parameters. The first parameter is going to tell us exactly which Transformers pipeline to use, and the second parameter is going to limit the number of inputs to 100 just to keep this pipeline quick for execution purposes. Finally, we'll call our function just like a regular Python function, and the result will be the featureized data that we asked Aqueduct to compute. Next, we're going to go ahead and define our inference function. Again, the code here is adapted directly from what's specified in the Transformers package, so I won't explain the code in detail, but you can see that similar to before, we've added the @op decorator, the same engine, the same requirements, but in this case, we've also asked for a GPU. The container that Aqueduct runs this code in, as a result of that, will actually have CUDA automatically installed and pre-configured to run with the code that you have here. In our code, using the PyTorch APIs, we can send our model to CUDA, we can send our data to CUDA down here, and use our GPU without requiring any additional configuration from our end. Again, we can call our predict function just like a regular Python function and receive a handle to our predictions. With this done, we're going to define a few final steps in our pipeline. First, we're going to process our predictions to take the sentiment scores that the transformers pipeline gave us and label them based on which score was the strongest. -1 for neutral, -1 for negative, 0 for neutral, and 1 for positive. We'll process our predictions, and we'll use the Aqueduct metrics API to actually calculate the average confidence the model has in the tweets that labeled as positive versus negative versus neutral. And that's it. We finished creating our workflow, and we can ask Aqueduct to capture the labels and the metrics associated with it and everything that was required to publish that information. We can publish our workflow, and now we can move to the Aqueduct UI to see the visibility that Aqueduct gives us. When we come to the Aqueduct UI, we can see a full visualization of the workflow that we just created right here in the browser. At any point in this workflow, we can click into a node and see a preview of some of the information related to that stage. Here we see a preview of the original tweets dataset that we based the workflow off of. We can click into a function and see the code snippet for that function that was run. And we can also see that this function, both the process function here, as well as the predict function here, are marked as running on our EKS US East 2 cluster. When we look at the code snippet itself, we can see that the configuration parameters that we specified, like where the Kubernetes cluster is, the requirements, and the resources, are all right here in the notebook as well. Finally, we can go over to our metrics that we defined earlier and see the average confidence the model had in each of the 3 metrics that we defined. All of this information is available as a part of the Aqueduct open source project right here on the UI. And that's it for today. We hope this gave you a better sense of how to set up and run a workflow on Kubernetes using Aqueduct. If you're interested in learning more, you can find a link to the Aqueduct open source project in the description below, as well as a link to our documentation for how to set up and use Kubernetes. We'll also include links for the Hugging Face model used in this example. Let us know if you have any questions, and we'd love to hear from you if you have thoughts or feedback on what we're building. Thank you.